All right, guys. Happy Monday. I hope you all had a great weekend. I definitely did. The Eagles are going to the Super Bowl, so we're going to use a little green here to celebrate. Let's go to activate our prior knowledge. We're talking about percent error today. So, Breanna Stewart and Steph Curry are on the basketball court. Curry stands next to a hoop and shoots, missing the hoop by 6 inches. 6 inches here. Stewart shoots the same hoop, but while standing at the opposite end of the court. She also misses the hoop by 6 inches. So here's my question. Would you describe these two as shots as equally bad? Why or why not? Okay. So are we saying that these shots are equally bad? So my question, I'm going to restate it, is are Steph Curry and Breanna Stewart, do they have an equally bad mistake based on where they missed? And so let's read again. Breanna Stewart and Steph Curry are on a basketball court. Curry stands next to a hoop, and this seems really important, and shoots, missing the hoop by 6 inches. Stewart shoots the same hoop, but while standing at the opposite end of the court. She also misses by 6 inches. So here's my question. Are they equally bad? Why or why not? Well, I'm going to draw a little, not that great diagram of a basketball court, right? So I have this thing right here, and I have this thing right here, and I got my little basket, okay? And here's Steph Curry. Okay, and he misses by 6 inches. And here's Breanna Stewart, and she misses by 6 inches. So my question here is, were they equally bad? And I'm thinking to myself, no, because Steph Curry is much closer to the hoop. So if he misses by 6 inches, he had a much less margin of error. He had a much greater margin of error than Breanna, who was standing at the other side of the court and only misses by 6 inches. Okay, so no, because Curry is closer to the basket. All right. And so we would say he had a larger margin of error. He made the bigger error based on his proximity to the basket. And so we're going to talk about margin of error today. I'm going to go down. All right. So we have Kayla. She's filling up a bathtub. She estimated that the bathtub had a volume of 60 gallons, but it actually held 50 gallons of water. So my first question is, how far off? How far off was Kayla's estimate? And I'm going to figure that out just by going 60 minus 50 is equal to 10, right? So this was her estimate minus the actual gave her 10, which is how far off. And that's not her percent error, but that is her error. So calculate Kayla's error as a percentage of the correct volume of the bathtub, okay? So basically what I need to do is I need to say, okay, the percent error times the original, which in this case is going to be, we'll call it the actual, is equal to 10, all right, which is the error. So I'm going to divide by 50, divide by 50. And so Kayla's percent error is 10, divided by 50 is going to be 0.2, okay? Which as a percentage, I move that over 2. So there's a 20% error here. She has a 20% margin of error. Now you might be asking yourself, this is a percent problem. It's like a little different than what we did. First of all, I didn't really use 60 in my formula down here. The 60 is important to find this number, right? How far off it was, but it's not actually going to go into your calculation of percent error. And I promise you that this is probably going to be the biggest mistake that I see, mostly because I made the mistake a few times just through sloppiness or being tired. So we're going to be super careful not to make this mistake. Let me continue down here. LeBron James guessed that he could make 400 three-point shots during practice. However, he was only able to make 320. Carmelo Anthony guessed that he could make 200 threes in a practice, but he was only able to make 120. Which person had the lesser percent error? Okay, so which person is kind of my question here, had the lesser percent error? All right, so this is his estimate. This is his actual for LeBron. We have our estimate for Carmelo and his actual. And let's move down here. I'll do my key information box. Right. So for for LeBron James from Carmelo Anthony, we had estimate 320, actual. Oh, whoops. A little better. My KIV. So LeBron James and Carmelo Anthony. His estimate, LeBron was 400. His actual was 320. And for Carmelo Anthony, his estimate was 200. His actual was 120. All right, so then my percent error, I do not know. Okay, so I need to find the difference. Try to make my work as neat as possible. Don't know how I did that. Okay, cool. My work neat. This. I'm going to reluctantly change colors here. I love the green tonight. All right, so LeBron James, he said I can make 400. He actually made 320. Okay, so his difference was 80. All right, and so I'm going to go, his percent error is equal to his actual, which was 320. Okay, times his actual, sorry, is equal to his error. Divide both sides by 320. Divide both sides by 320. Okay, and so I have 80 divided by 320. I have 25.25, which we're going to call zoop zoop 25%. So LeBron James had a 25% error. All right, so Carmelo Anthony, he said, I can do 200 shots but he only did 120. So he also has the error of 80. Okay, and so I'm going to go my percent times 120 is equal to 80, which was my new. Divide both sides by 120. Divide both sides by 120. I'm going to say 80 divided by 120 gives me 66.6 repeating percent. So the question was, look up a little bit, which person had the lesser percent error? So my answer is that LeBron had the lesser percent error. Little box around it. All right. Well, you're going to move right along. Go down here. All right. Mr. Adams keeps a large jar of jelly beans in his classroom. The student who guesses closest to the actual amount will win the whole jar. Rajan guesses 57 jelly beans. It turns out there are 50 jelly beans in the jar. How far off was Rajan's guess? Okay, so here's my question here. How far off was the guess? And so here I'm looking for a number, not the percent, right? So I'm looking for the difference between the estimated and the actual. Estimated minus actual. Okay, so let's go back here. Mr. Adams keeps a large jar of jelly bean, blah, blah, blah. The student who guesses closest to the actual amount wins the whole jar. Yay. He guesses 57 jelly beans, right? So that's his estimate. It turns out that there are 50 jelly beans in the jar. That's his actual. Okay, so he is going to go 57 minus 50 is going to give him 7. All right, so that's how far off he was. Now I want to know what was his percent error. Okay, and that's where I'm going to bring in this equation I was doing. So I have my percent times my actual, or my original, which was 50, is equal to my error, which was 7. I'll divide both sides by 50. Divide both sides by 50. 7 divided by 50. Give me 14%. So my answer here is C. I have a 14% error. I want to skip down to homework, so I'll meet you there in a second. Okay, we'll take a look at number 1 in the homework here. Makai uses his thermometer and finds the boiling point of ethyl alcohol to be 75 degrees Celsius. He looks in a reference book and finds out that the actual boiling point of ethyl alcohol is 80 degrees Celsius. So what was his percent error? So here I'm finding percent error. That means I do have to take that extra step just beyond finding the difference. All right, so let's do my key information box. I'm going to say the estimate is equal to 75 degrees Celsius. The actual boiling point is 80 degrees Celsius, and we need the percent error, which we do not know. So let's go ahead and set this up. First, I'm going to find the difference between 80 and 75. 80 minus 75 is going to give me 5. I'm going to go percent times, this is my actual, is equal to 5. Divide both sides by 80. Divide both sides by 80. Notice I don't care necessarily how far away, sorry, if it's more or less, the percent error, if the actual is more or less. I'm finding the sort of absolute value of the error, which in this case is 5. So I'm going to do 5 divided by 80. Okay, and so I had so it gives me 0.0625. If I move my decimal over, I have a 6.25% error. Okay, so with that, gentlemen, good luck. We will see you tomorrow.